which uses all the information we've just calculated, and now they say determine the value of n, which is that y coordinate of the turning point. Now normally if you had the equation of the parabola, this would have been very easy. You find the axis of symmetry using x is equal to minus b over 2a, you know that formula for the axis of symmetry.
Yeah.
You would find the axis of symmetry, which would then give you a quarter, and then you substitute a quarter into your original equation to find the y coordinate, which is that value of n. That's how you'd normally do it. You find the axis of symmetry using that formula, substitute it into the original equation, and then you find the y value of the turning point.
Yeah, okay.
Okay. But now we don't know the equation. So it doesn't help much because we don't know the equation of this parabola. So we need to try and find another way of getting the value of n.
You see, that's where I would have messed up. Then I would have totally, see, that's when I don't know when to change things, because I would have still been looking for the formula for the parabola.
Okay, which you don't have.
Yeah.
But we can calculate it.
The formula.
Yeah. Let's start with the standard formula for a parabola. Y is equal to ax squared plus bx
plus
C.
plus c.
We have the value of c. That's 6. Do you agree?
Okay, I don't understand that.
C, the value of c at the end of your equation is the y-intercept.
Okay, yeah.
And we know the parabola passes through the y-axis at 6. And we have a zillion points that we could use, but let's use that point there since it's not on any of the axes. So we could say the value for y is 6 is equal to a, the value for x that we use there is a half, squared plus b times a half for x plus 6. Do you agree with that formula I've just compiled there?
Yeah, I do.
Alright, so let's just simplify that a little bit further, just to get rid of all the squares and the fractions as far as possible. So we'll get a quarter a plus a half b plus 6.
Yeah.
Right? And ultimately those two 6's will cancel each other out, and we can multiply right through with a common denominator, which is 4 over 1. So we're going to get 0 is equal to a plus 2b. You happy?
Yep.
Okay, now we've got an equation with two variables. Immediately now, having an equation with two variables should put your mind in motion for one specific technique. One equation, two variables. It's like a keyword, you know, it's like a red light and an alarm going off. It should point you into a certain direction. Do you know what that is?
Quadratic equation?
No. Almost there, but not quite. If you don't know, tell me.
Yeah, I don't know.
Okay, Jason, let me repeat that whole line for you, because this needs to be imprinted in your brain. If you have one equation with two variables, it should indicate the use of simultaneous equations, which means we have one of the two equations that we would be looking for already.
Okay. Alright, yeah, okay.
So we
I
need
see
another
now.
equation also containing A and B.
Yeah.
So where are we going to find another equation also containing A and B? Let's go back to the drawing.
Another equation.
How did we get that equation in the first place?
Well, we were trying to work out the formula for the parabola, and we used the one coordinate.
Yes, but how did we get that? Yes. Now, don't you have other points on the parabola as well? I mean, you have that point there, and you have that point there as well. So you could actually compile another two equations from the standard equation, also containing A and B.
Oh, alright, I see.
Okay, but those other 2 points are on the axis. So we would normally prefer not to work with any point which is on the axis. Alright?
Okay, so then...
Unless you really don't have a choice. So we could use that formula.
Oh, alright, I see now.
It also contains A's and B's. And we know that the value of x is a quarter. So we could say a quarter is equal to minus b over 2a.
So, yeah. Okay.
Alright, and then to simplify, let's just cross multiply. That will give us 2a is equal to minus 4b. So a is equal to minus 2b. Do you agree with me?
Yeah.
Which is equation number 2. Now, my question to you. Do you know how to solve simultaneous equations?
Yep.
Okay, so take me through the next step. What is the obvious logic of the next step?
Well, you solve for one of the two. So you choose the easiest one to work with.
Okay, but we already have that.
Yeah.
You're quite right, but we are lucky. We already have it solved for A.
So then you just take A. You take what A is equal to and you substitute it into the first.
Thank you. So we substitute it into equation number 1, which will give us minus 2b plus 2b is equal to 0. Okay, so we have 0 is equal to 0.
Okay, that's odd. That's okay. I don't know what to do from here.
Yeah. Well, obviously, what does that? No. It obviously points to a problem. Okay, we have a problem. Somewhere along the line, we now have a problem. We need to go back and see what we did wrong. Because 0 is equal to 0, but we haven't solved anything. We've just proven that 0 is equal to 0.
Yeah. Well, can we use other coordinates, maybe?
Okay, we could. Let's just consider why this happened. It happened because that point there has the same y coordinate as the axis of symmetry. So we had those two values there cancelling each other out.
Oh, I see.